Hi guys, I am Prajwal V from SVC Engineering College, Bangalore, and my branch is CSE Data Science of first year and the first sem. Today I am going to tell the topic of Introduction to the C, means C programming. Now let's get into the topic Introduction to the C programming. Welcome to C programming. This guide is designed for beginners who want to learn the fundamentals of programming. C is a powerful language that forms the basis for many other languages. Let's embark on this exciting journey together. Why should we learn C? C is versatility and efficient programming language. It serves as the foundation for many modern languages like C++, Java, and Python. Understanding C will enhance your problem solving skills and provide a strong base for future learning. Now I am in another point, setting up your environment. To start the programming in C, you need to set up your development environment. Download a compiler, C compiler like GCC, or use an IDE like Codes, Blocks, or Visual Studios. This setup allows you to write, compile, and run your C programs effectively. Basic syntax and structure. C program consists of functions with the main. They are shown in the curved brackets. Function being the entry point. The syntax includes data types, variables, and operators. Understanding the basic structure is of writing effective code and avoiding common syntax errors. Control structures like if else, for, and while loops are in C programming. They allow you to flow of your program based on conditions. Mastering their concepts is vital for creating dynamic and inactive applications. The next point is functions in C. Functions are the building blocks of C programs. They help organize code into reusable blocks. Understanding how to define and call functions will enable you to write more efficient and manageable code and enhancing your programming skills. Now let's move to another point. The next point is debugging techniques. Debugging techniques is a essential skill in programming. Learn to identify and fix errors in your code effectively. Utilize tools like GDB or built-in debugs in your IDE to step through your code and understand its behavior. Now I am going to say about the quadratic equation. How can we use it in C programming? Introduction to the quadratic equation. In this guide, we will explore quadratic equation and how to solve them using the C programming language. Quadratic equation are the form of ax square plus bx plus c equals 0. Understanding this solution is for many applications in mathematics and engineering. And see the another point. The another point is understanding quadratic equation. A quadratic equation is represented by the formula ax square plus bx plus c equals 0, where a comma b comma and c are constants. The solution to this equation can be found using the quadratic formula x is equal to minus b plus or minus square root of b square minus 4ac by 2a. This formula helps us find real and complex roots. The next point is calculating the determinant. The determinant is a vital part of solving quadratic equation, calculated as d is equal to b square minus 4ac. It helps determine the number of real roots. If d is greater than 0, there are two distinct real roots. If d equals 0, there is one real root, and if d less than 0, the roots are complex. The next point is implementing the quadratic formula. Once you have the discriminant implement the quadratic formula in your C program. Use conditional statements to handle different cases based on the value of the discriminant. This ensures that your program can accurately calculate and display the roots of the quadratic equation. The conclusion of quadratic equation. In conclusion, solving quadratic equation in C involves understanding the equation structure, calculating the determinant, and implementing the quadratic formula. Mastering these steps not only enhance your programming skills but also strengthens your mathematical foundation. Next, we can see the loops in C. Introduction to the loops in C. Loops are fundamental programming constructs that enable repetition of code blocks in C. The while loop and do while loops are essential for controlling the flow of execution based on conditions. This presentation will explore their syntax, usage, and key differences to enhance your understanding of their constructs. The next point is understanding the while loop. The while loop is C repeatedly execute a block of code as long as specified condition remains true. The syntax is simple while conditions. As we see, there are usually a flower brackets. It is the condition. It's ensure that the condition eventually become false to avoid infinite loops. The next point is example for while loops. Consider a sensor where we want to print number from 1 to 5 using a while loop. We initialize a counter, check the condition and increment in within the loops. This example illustrates how to control the loop's execution flow effectively. The next point is exploring the do while loop. Do while loop is similar to the while loop, but it guarantees that the code block executes at least once. The syntax is do. As shown in the loops, they are put at the two flower brackets as shown in the slide, and while condition. This is particularly useful when the initial condition check should happen after the first execution. Let's see the example of do while loops. An example of do while loops can be seen in user input validation. The loops will promote the user for input and validate it, ensuring that the prompt appears at least once regardless of the input. This showcases the unique behavior of do while loops. Of loops constructs. Mastering loops in C, specifically the while and do while constructs, is crucial for efficient programming. Understanding their difference and appreciate use cases can significantly enhance your coding skills. Practice implementing these loops to solidify your knowledge. The next concept is input and output statement in C programming. Then see what are these. Welcome to the world of C programming. This presentation will guide you through the essential of input and output statements. Understanding these concepts is crucial for creating inactive and dynamic applications. Let's embark on this journey to master the art of communication in C. Then see what are the input statements. Input statements in C allow programs to receive data from users. They are essential for creating inactive applications. The most common input functions in scanf, which reads format input. Understanding how to effectively use input statements is key to enhancing user experiencing and program functionality. The next point is using scanf function. The scanf function is a powerful tool for the capturing using input. It can read various data types like int, float, and chr. It means the character properly using format specifies ensures data incorrectly interrupted mastering. This function will empower you to create versatility and responsive applications. Then see the output statements explained. Output statements are crucial for displaying results to users. The primary output functions in C is printf. This function allows for formatted output, making it easier to present data clearly. Understanding how to the structure your output will significantly enhance the readability of your programs. Using printf functions. The printf function is versatility and powerful. It can display strings, numbers, and even formatted data by mastering format specifies your you can control how information is presented. This skill is vital for creating professional and polished applications that effectively communicate results. Combining input and output. Combining input and output statements creates a dynamic interaction between the users and the programs. From example, taking user input and displaying results based on that input enhance engagement. This is essential for developing applications that responds to user needs. Common pitfalls to avoid. Even experienced programs can stumble with input and output statements. Common mistakes include format specifiers and improper data handling. Being aware of these pitfalls will help you write more and error free code, ensure a smoother programming experience. Best practices for clarity. To ensure clarity in your programs, always validate user input and provide clear output message. Use commands to explain complex sections of code. Following these best practices will not only improve readability but also make your code easier to maintain and debug. The next point is Pillar 3 modularity. The modularity of C allows developers to break programs into smaller, manageable pieces. This approach enhances code organization and reusability, make it easier to maintain and update software projects over time. The next point is memory management in C. C provides powerful tools for manual memory management. Understanding pointer and dynamic memory allocation is essential for optimizing performance and avoiding common pitfalls like memory leaks. The next point is standard libraries. The standard libraries in C offer a rich set of functions that simplify tasks such as input, output operations, strings manipulation, and mathematical computations. Leveraging these libraries can significantly improve development efficiency. Error handling techniques. Effective error handling in C is crucial for robust Applications techniques such as written codes and association help developers identify and manage errors, leading to more stable and reliable software. Future of C programming. Despite the emergence of new language, C remains relevant due to its performance and control over system resource. Understanding its principles lays a solid foundation for exploring modern programming paradigms. Now let's move to the another topic called pointer in C programming. Introduction to the pointer. In C programming, pointer are variable that store the address of another variable. Understanding pointer is crucial for efficient memory management. This presentation will explore pointer to pointer concepts, enabling you to unlock the power of indirection and enhance your coding skills. The next point is, what is a pointer to pointer? A pointer to pointer is a variable that stores the address of another pointer. This adds an extra layer of indirection, allowing for more complex data structure. Understanding this concept is essential for managing dynamic memory and multi-dimensional arrays effectively. Benefits of using pointer to pointer. It simplifies the management of dynamic arrays and linked lists. It allows for more flexible memory allocation and can help in passing pointer to function without losing the original reference, enhancing your program's efficiency. In common use cases, pointer to pointer is often used in dynamic memories allocation, handling two-dimensional arrays, and creating linked data structure. Recognizing when to use these techniques can greatly improve your program's performance and memory usage. And the last is conclusion. Mastering point to pointer is crucial for advanced C programming. It enhances your ability to manage memory and build complex data structures efficiently. By understanding its use and potential pitfalls, you can unlock the true power of indirection in your codes.